Welcome to Quadratics Completing the Square. Did you wake screaming in the night? I really do hope not. This is the next part of the tutorial about quadratics and using the idea of completing the square. Maybe a little recap is in order? Maybe. The important language you're going to use is pretty much the same as we did in the last video. Curves, quadratics, maximum, minimum, and turning points, because these are pretty much important to us to understand how to effectively sketch quadratics and those important parts. Let's go back just very quickly to the idea of completing the square form. What is completing the square form? Well, pretty much what is shown on the whiteboard. We like equations written in this way. This is a quadratic equation. We've already discovered that in a previous video. And the way it's written helps us work out where our turning point is. That's pretty much why it's called the turning point form. So if you have the equation y equals x plus 1 squared minus 3, we know that the value inside the bracket, because it's connected to the x, is a horizontal shift. Now, whereas we think that plus 1 would normally move it to the right, because it's inside those brackets, we effectively say it does the opposite thing, and so my graph is going to move 1 unit that way. My standard quadratic. This minus 3, if you remember rightly, tells us that this is going to be a vertical shift in the right way. So a minus 3 would move it down 3 points. So our turning point on this graph would be at the coordinate position 1, 3, and it would be a minimum because this graph doesn't have a negative sign in front of it. Now, we like things written this way because it's helpful to us to find that minimum. Unfortunately, with maths being a big fat trick, life tends to get a little bit more complicated. This is also a quadratic equation. It's got our highest floating number of a squared, and it's got 3 other terms. Interestingly though, it looks nothing like our completing the square form. Well, this here is called the intercept form. Why? Well, simply because it allows us to find our intercept of our graph quite quickly. You remember that the intercept on the y-axis is when x equals 0, and if we look at our equation and let x equal 0, this x squared term disappears, this plus 2x term disappears, and we get left with this minus 2. And in general, the value on the end here, this minus 2, is effectively allowing us to say what our intercept is. This isn't a particularly helpful form if we want to try and find maximums and minimums. So is there a way of getting between these two forms? Actually, yes, and it is called completing the square. If I have y equals x plus 2 squared, can I write that in long form? Can I actually multiply out the brackets? Well, of course we can. We can FOIL it. And that just means x plus 2 multiplied by x plus 2. In another video, we worked out that x times x and x times positive 2 and positive 2 times x and positive 2 times positive 2 is how you multiply out that bracket. And so x times x gives me x squared, x times positive 2 gives me positive 2x, positive 2 times x gives me positive 2x, and positive 2 times positive 2 gives me positive 4. X squared, 2x plus 2x is positive 4x plus 4. And so we know that x plus 2 all squared is equal to x squared plus 4x plus 4. Well, can we use this result here to help me find x squared plus 4x plus 3? Well, I suppose logically, if we look at the differences between the equations, to go from here to here, I've literally just taken 1 off that last number. So if I've taken 1 off that last number, can I do anything here? Yes, absolutely the same thing. You write x plus 2 squared minus 1. Ah, that looks pretty familiar. X plus 2 squared minus 1. That's looking more like my completing the square form. Can we use the same idea to go from, well, what if I wanted x squared plus 4x plus 10, for example? Same idea. We know that to go from here to here, we've gone from plus 4 to plus 10, so I just need to plus 6, which means I need to do the same thing to this bracket here, because we know that this bracket gives us this expression. So I know that that is going to be exactly the same as x plus 2 squared plus 6. Ooh, this is pretty awesome, pretty exciting. Can I use this in any way to help us find other equations? Or is there any similarity between what we are looking for and what we end up with? Well, let's have a look. I have x squared plus 4x plus 10, and that ends up as x plus 2 squared plus 6. Well, I notice, interestingly, that this value here, that this plus 4 is halved to get to here. Does that work in other ways? Well, actually, yes, it does. That's pretty much the trick to completing a square. Well, that sounds pretty easy. Actually, it really is. Let's have a couple of examples and see what we can come up with using this general idea. What if we have y equals x plus 3 squared? If I multiply that out, I get x squared plus 6x plus 9. So this here gives me this, and what do I notice? This plus 3 and this plus 6. Plus 6 is halved and inside. What if I have y equals x plus 10 all squared? What do I get? I get x squared plus 20x plus 100. And again, this value, halved or double depending on which way you look at it. And again, if I wanted to find, using the same ideas we did before, if I've got now x squared plus 20x plus 101, for example, turning that back to a squared, then how do I go from here to here? I would simply add 1. So how do I get to the completing the square form? Well, it must be the same as x plus 10 squared plus 1. Right, I think we've pretty much got the idea. Let's see whether we can go backwards. I now have the equation y equals x squared plus 2x minus 2. Well, we've noticed that this value here is halved and seems to be what ends up inside my brackets. So let's do that. I've got my x, half of plus 2 is plus 1, and square it. So now the only complicated bit is, well, how do we find out this number that sits on the end here? Well, what do we notice about this plus 10 and this number here, this 100? What did I notice about the plus 3 and this number here, the plus 9? Well, it's the square. 3 squared is 9, 10 squared is 100. So what happens if we square this out? Well, 1 squared is 1. Thing is, I don't want 1. I've noticed that my equation here needs negative 2. Well, if I've got 1 and I want to get to negative 2, then I simply take 3 away. Wow! And there is my completing the square form, using what I think is pretty simple maths. So there we go. There's our equation we've just been working on. Y equals x squared plus 2x minus 2. We'll just do the question very quickly again. So we have y equals x squared plus 2x minus 2. How do we complete the square? Well, it's half of this middle number goes inside. X plus 1 squared gives me my actual squared. And how does that help? Well, remember, to find the number that we need to go after here, we square this. Plus 1 squared is 1. We want negative 2. How do I go from positive 1 to negative 2? I simply take 3 away. And there is my completing the square form. Does that now mean I can draw this on a set of axes? Well, yeah, pretty much, because I actually have all the information now I need. If I was to draw my curve now, there we go, it's a U-shape. How do we know it's a U-shape? Because this value here, there's no negative in front of my x squared, so it's a U-shape. What does the plus 1 mean? It means it moves 1 unit that way. So we now know the minimum is at negative 1. And what do we know that the minus 3 means? It means the whole thing moves down 3 places. So I now know that there is negative 3. So I now know that my minimum point is minus 1 minus 3. That's pretty cool. Can we find the intercept? Yeah, the intercept now is given to us up here as -2. There is -2, and if this was a VCE or an A-level question, or even GCSE, then we would now have all the marks that we need because I've sketched my curve and I've placed onto that curve all my relevant information. Well, this stuff seems pretty easy. Another example? Yes, please. Right, slightly more complicated. We've got y equals x squared minus 12x plus 40. Let's write it out so we can actually work on it. Y equals x squared minus 12x plus 40. Following the rules that we've done before, what goes inside my brackets? An x, because that's x squared. Half of minus 12 is -6, and squared. How do we get this number? Well, we go back to here and we go, well, -6 times -6 is 36. I don't want 36, I want 40. How do I get from 36 to 40? I add 4. And there we go, by completing the square. Wow, this is quick and easy. Let's just see what that would look like. There's my graph. So what can we now tell? Well, we know the intercept, because the intercept is this value here from the intercept form, so that's going to be 40. That's going to cross there at the value of 40. What does this -6 mean? It means it moves that way, 6 places. So I've got 6 on my x-axis, and that +4 means that it moves up 4 places. So if I just do a little cross there and do 6, 4, I've just got all my marks. Obviously making sure we label my axes as well. This completing the square is now actually making graph drawing pretty easy. Another example? I think so. Right, well, 2x squared. Unfortunately, life becomes more complicated because completing the square works best when there is not a value in front of the x squared. It actually only really works when you've got x squared on its own. Well, that's not a major issue because what I can do is I can actually move 2 outside my brackets. Just follow through and watch what I do. So I'm going to take a factor of 2 outside my set of brackets. I'm going to divide every term by 2, but not get rid of it. You can't actually get rid of the 2. That leaves me x squared plus 6x plus 13 over 2. 13 over 2. Well, I'm going to write it as 13 over 2 for the moment. I'm now going to pretend my question has become y equals x squared plus 6x plus 13 over 2. Don't worry about that fraction. We'll come back to it in a moment. I'm breaking it out. Right, so let's complete the square of this bit. Well, follow the rules that we've done before. Put a bracket on my x. What is half of +6? It's +3. Close my brackets and put a squared. Right, I've got 3 inside the brackets. 3 squared is 9. I don't want 9. I want to get to this 13 over 2. So I've got, I'm just going to do a little calculation on the side. I want 9 and I want 13 over 2. Well, let's think what 13 over 2 is going to be 6.5 just in my head. So 9 to 6.5, I've got to take away 2.5. And what is 2.5 as a fraction? 5 over 2. Right, so that means that to go from 9 to 6.5, I've got to take away 5 over 2. And that goes on the end there. Well, but remember we broke this out. We just did this like a side calculation. We need to go back and put it back in our brackets just to keep it complete. So I've got y is equal to 2, and now square brackets to help us differentiate. X plus 3 squared minus 5 over 2. What does this 2 tell us to do? We now multiply out my brackets and I get 2 brackets x plus 3 squared minus, well, 2 times 5 over 2 is minus 5. And there we have our completing the square. Now you're probably going to turn around at this moment and say, well, hold on a moment, we haven't met a number in front of this before. All right, there's my plus 3 inside my brackets, there's a minus 5, I know what they do. What does this 2 do? Well, that's going to be called our squidge factor or our squish factor. What this 2 actually does is stretch my graph. It's a vertical stretch. It's a vertical stretch. It actually stretches my graph up. It stretches my graph up by a factor of 2. And what that really does is make my graph thinner. We'll come back to that later on because this is more about how to complete the square. What does that look like on a graph? There we go. So what you should notice if you compare this with the earlier part is that graph got a lot thinner than it was previously. Still has the same shape as a quadratic, but we have the information we need from our completing the square form to help us put important information on. Firstly, plus 13, this number here, what does it stand for? Yep, it's the y-intercept, so I can now write 13 on my graph. What else do I know? Right, we know that the graph has a minimum at, well, 3 to the left and 5 down because of the minus 5. So there is my minus 5 and there is my negative 3. We'll do a minus 3 comma minus 5, and we pretty much have all the information on our axes we would need to help us get full marks on the question. Well, sort of. Unfortunately, there are two other points on this graph that later on become important as well, and that's that point there and that point there. They are the x-axis intercepts, but again, that's a little bit beyond the scope of this. I think that's pretty much as hard as it gets, isn't it? Probably not. What about this minus sign? Minus 2x squared, does it change? Nope. Same idea as we had before. Let's write the question out. Y is equal to minus 2x squared plus 6x minus 8. Remember, the system only really works, is completing the square works when you have x squared on its own. So we take minus 2 outside of the set of brackets, gives us x squared, minus 3x. Remember, be very careful, because a minus and a minus makes the plus, and a minus 8 will become plus 4 inside my brackets, to allow me to now go off and break this out and complete the square. So let's now pretend our question is y equals x squared minus 3x plus 4. We know how to do this. We put a bracket and our x. Half of negative 3 is minus 1.5. Well, let's have that as 3 over 2 squared. Right, we need to get to plus 4. We've got minus 3 over 2 squared. Well, minus 3 over 2 squared is the same as 9 over 4. Why? Because you square the top numbers and the bottom numbers. That gives me 9 over 4. What's that in real numbers, or in my head? That's 2 1/4. And how do I go from 2 1/4 to 4? I need to add on 1 3/4. What's 1 3/4 as a top-heavy fraction? That's 7 over 4. So we need to add on 7 over 4, so there we go. We'll add 7 over 4 on, and that's our broken out done. What do? We put it back into my original breakout, remembering that we need to put the 2 outside a set of square brackets, x minus 3 over 2 all squared, plus 7 over 4. What does that give me? Well, multiply that out, gives me 2, mistake, minus 2, x minus 3 on 2 squared, plus, well, we multiply that by minus 2, so that's now going to become a minus. So minus 7 over 4 times 2 is 7 over 2. And there we have our completing the square form. Does it give us all the information I need to know? Yep, of course it does. It tells us this minus 2 now tells me my graph is going to look like that, but it's going to look a bit thinner. It's going to be squidged, to use my term. This minus 3 on 2 means it's going to be moved that way and have a minimum at 3 over 2 for the x, and it's going to be moved down 7 over 2. How's it going to look? A little bit like this. Right? Excuse the fact that most of the graph seems to be missing. So what information can I put on? Well, we know the intercept because it's minus 8. We take that from the top. So there's my intercept of minus 8. We know that this x coordinate is 3 over 2. We know this y coordinate is 7 over 2. And so let's just put a little cross here and make it definitely sure that the examiners know that I know what I'm doing, and that is my completing the square. Even with fractions in it, it still works exactly the same way. Yep, we're almost finished, but there is unfortunately one question that we need to look at, because maths being a big fat trick means that they start throwing in algebra. We're not bothered about algebra anymore, are we? Hopefully not. This is just an example to show you how to do it, but it works in exactly the same way. I have y equals x squared minus 2kx plus 1. Complete the square in the same way as we've done before. We don't have to worry about taking anything outside the brackets because this is just an x squared term on its own. So we have y equals, open a set of brackets, x. I've got minus 2kx. What does the rule state? The rule states we half the number in front of the x. Doesn't matter if it's got a letter. Half of minus 2k is minus k. Just one of them, and we put the squared in. Right, well, if I multiply this bracket out, what does it give me? Well, it'll give me k squared. I don't want k squared, I want plus 1. So what does that mean I've got to do? It means I've got to take away the k squared I'm going to get and add the one I want. And there we go. Even using algebra, this seems relatively simple. Wow! You can ask me how we sketch that. Don't worry about it. You probably won't have to sketch it at this moment in time. Hopefully that's been useful. This is the end of Quadratics completing the square. We'll see you next time.